Hi there everyone, in this video we're going to be going through the inverse normal distribution. So that is problems that are a little bit different from the last one where we were calculating the values of the area underneath the curve, which is the exact same as probability. In these questions that we're going to do now, I'm going to give you an area under the curve or give you a probability and ask you to find the x values along the axis. So let me demonstrate the difference between those two. In the previous video, I gave you the mean. So let's say the mean was 50, the standard deviation was 10, 60, 70, 80. And I said, what's the probability that we randomly choose somebody that they weigh over 60? So in these questions here, I'm asking you to find the area under the curve or the probability of that happening. Now, in these videos here, we're going to do slightly differently. I'm also going to give you the mean and give you the standard deviation. There's going to be 60, 70, etc. And I'm going to say, let's say 20% of the people, let's say this is heights, 20% of the people are higher than what height in whatever this is small pygmy people, obviously. So I'm asking, what is that value right there for these pygmies? That 20% of the pygmies are taller than, or you could ask the question, what's the height so that 80% are shorter than this particular value? This is an inverse normal problem where I'm giving you the area or the probability and you have to actually find out the value on the axis there. Here's how you do it on your calculator, because the syllabus says we just need to use our calculator to do this, which is great. So in this normal distribution, the mean is 65, the standard deviation is 12. We're talking about weights, population of weights. What is W so that the probability X is greater than W is 0.25? Now, I strongly suggest for your future well-being doing these questions that you draw a normal distribution so you can see what's going on. Really, really helpful. So let me draw one over here on the right. So we've got a mean of 65 and a standard deviation of 12. And the question says, what is the value of W? So the chance X is bigger than W is 0.25. Okay. So this is an inverse normal problem. That's 0.25, that area up there, and that is W. Okay. That's what we're asking. The chance that we're greater than W is 0.25. What is the value of W? And this is the distribution for X. Okay, so on our calculator, it is the inverse normal. So interactive, again, distribution, grab your calculator and just make sure that you get these values. Interactive, distribution, now inverse and inverse normal, CDF, inv norm CDF. And then it's going to give you this pop-up here. So the tail setting is the right. Here we're looking for the area on the right-hand side. You can clearly see from the diagram the 0.25 is on the right. The probability one is 0.25. We put in the standard deviation and the mean. Click on OK, and it gives us a value of 73.09. So I'll round that to 73.1. Now let's just go back to our diagram and see if that looks good. Okay, yep, that looks pretty good to me. So they're saying that W here is 73.1. So you can look at the diagram and think, yep, that sounds reasonable. So 73.1 kilos is, in this case, the upper quartile. The value for which 25% of the values are bigger than, 75% of the values are less than. So it's called the upper quartile. Now, while I'm talking about that, I might as well talk about quantiles, which is a fancy name to talk about any type of percentile on the normal distribution. So when we talk about quartiles, the lower quartile is the 25th percentile or the 25th quantile. So as it's got here, the quantiles are the values for which a particular proportion of the distribution falls below. So on the one we just did, it was the 75th quantile. In this example here, we've got the 70th or the 70th percentile or the 70th quantile, the 0.7 quantile, if you like. Okay, so just a word that you need to be aware of. Okay, here's a slightly different question. What is W so that 90% of the weights lie within W kilos of the mean. Again, draw a normal distribution. Here I go again with my normal distribution. Sorry, it's not very good. Gee, that's really bad. It's even worse, but I'm giving up. 65 is the middle. We want to know W. Let's read it again. What is W? So that 90% of the weights lie within W kilos of the mean. Okay, so W is, in this case, this distance here. Okay, and this area in here is 90% of the whole area underneath the curve. Okay, this is an inverse normal problem because I'm giving you the area and you have to find out the value. So what I'm going to do is get my calculator to find that value, and then it's going to be easy to find that value there because that's W as well, the distance from the mean. So here's how we do it on our calculator. Again, same thing. We're going to go inverse normal, so it's the same keystrokes as we had before here. So interactive, distribution, inverse normal, CDF. The tail setting now in this case is center. All right, so we want the middle 90%. So the probability now is 0.9. We've got the standard deviation and the mean, and we hit OK. And this is what it spits out, 45.26. Now that happens to be the low value here that it spits out. Don't ask me why, but it gives you the lower one here, 45.26. I mean, you could easily work out the top one just by symmetry there. But what we're really interested here is this value of W. So we just go 65 minus that value, and we get 19.74, rounded to 2 decimal places. So 19.74 kilos. So see if we've answered the question. What is W? So that 90% of the weights lie within W kilos of the mean. Yep. 90% of the weights lie within 19.74 kilos of the mean in this case. Beautiful. Okay, really quickly, this example here. V is a random variable with mean 420,000, standard deviation 28,000. So this random variable might be the selling price of houses. And obviously, for this thing to be normally distributed, you're going to need a lot of data here. You can't just take 10 houses. This is going to be a lot of data put together and would be normally distributed. So let's talk about average selling price of a house. Find the 40% quantile. Again, you guys could probably just do it on your calculator, but I strongly suggest that you're going to write this out. So the mean here is 420k, 420,000, and the 40th quantile, that's this value right here. So the percentage down there is 40% of the whole graph. Okay, so on your calculator you need to know what moves or what you're going to write in on your calculator here. So go for it. So let's look at the value that you should have found there. So you're going the inverse CDF here for the normal distribution, inverse normal CDF. You're looking at the left tail, okay, not the right tail, so the left tail. Probability is 0.4. The standard deviation is 28,000. The mean is 420,000. And you put all that in on your calculator and you get that. So 412,906. is the 40th percentile, if you like, or quantile. Second question, the value of A is such that probably V is greater than A is 0.27. Let's draw it out. 420,000 here in the middle. The value of A is such that the probability V is greater than this value is 0.27. So you can tell from this statement here that it's going to be to the right of the mean because the chance that A is bigger than this is 0.27. So that area there is 0.27 or 27%, and that is the value we're trying to find. This is the random variable V, so that's the value of A. So you can see clearly from the diagram that A is bigger than 420,000. Okay, so here the tail setting is right, probability 0.27, standard deviation, mean, put it all in your calculator. I think this is pretty boring because you just do it on your calculator. You don't have to do all the hard work. And you get $437,158.76. Okay, check this one out. 8,240 students are given an IQ test. The scores were normally distributed with a mean of 100 and a standard deviation of 16. Determine how many of these students to the nearest 10 achieved a score in excess of 128. Okay, so this one's, I guess, it's 1 degree harder. All we're getting to do here is work out the probability that any one student achieved a score in excess of 128 and multiply that by the total number of students that we have, and that will give us the estimate of how many students. Then we just need to round correctly. So again, please draw a normal distribution and make some probability statements here. So here's our normal distribution, which you're going to be better at than me. The mean's 100. There we go. And students to the nearest 10 achieved a score in excess of 128. Okay, so this isn't inverse normal anymore. This is back to the normal stuff. You grab your calculator. You know this is just norm CDF. You've got the value, you've got the mean, you've got the standard deviation. You put it in, and you should get that area there is 0.0401. Just check your calculator that you get that. So the answer to the problem then is times 8,240, which is how many students we've got. So that's approximately, to the nearest 10, 330 students. Just check that on your calculator that you get that value. For part B, this is the inverse normal part. What were the minimum and maximum scores of the middle 60% of students on this test? Okay, the middle 60%. Here we go. So here we go. I'll call this P and Q. That I've just shaded is 60% of the whole graph here. Now, I'm going to diverge here and say that this problem is a lot harder if you do not have your calculator, because you've got to think in terms of the standard normal distribution, because that's the only tables and actual values that we normally have. So with the standard normal distribution, mean 0, standard deviation of 1, you actually have to find what these z values are. The z values are the values for the standard normal distribution. Now, because this thing has a standard deviation of 1, a z value just tells you how many standard deviations from the mean you are. So in this case here, if this whole shaded area here is 60%, this little bit here is going to be 30%. So when we're looking up z values, it's always from a value down. Okay, so if this little bit in here is 30%, we know the whole area underneath this is at 1, so this area down here is 0.5. So the area from this value all the way down is 0.5 plus 0.3 is 0.8. So on your z value tables, you'd be looking for, well, what's the z value such that 80% of the values are less than that particular z value? So it's the 80th percentile or the 80th quantile that you'd be looking up in your tables. That would give you a z value for that right there. So I can't do it. I haven't got a calculator with me right now. But let's say that that's 1.4. I'm just making this up. So let's say that's 1.4 standard deviations above the mean. Okay, remember the formula that we use to calculate these z values. The z values are just how many standard deviations above the mean are you? So here's the formula. This tells me our value. This is the mean. So we subtract those two. It tells me how much bigger than the mean we are or less. Divide by the standard deviation. So that told me how many standard deviations above or below the mean. So in this case here, I've got the z value, 1.4. I've got the standard deviation, which was, in this case, 16. I know the mean is 100. Now I can work out the x value. So this is an inverse normal problem. This is what it looks like for the history of the world before calculators were involved. So times by 16 and add 100, and that would give you the answer for your x value, which is clearly bigger than 100 there. So this is how us mortals did it back in the 1970s and 80s and 90s and 2000s. And I think it's still important that you know and appreciate how that works. On your calculator for B, so let's do the easy way. you'd do the inverse normal thing on your calculator. You'd be looking for the center feature. You'd put in 0.6, you'd put in the standard deviation and then the mean. It would give you the lower value down here. So do that on your calculator and tell me what you get. It should be 86.53. Once I know that the lower one is 86.53, I can just subtract 100 minus 86.53, whatever that is, add that onto 100, and that gives us the value of Q because there is a symmetry going on there. So if you do that, you should get Q is 113.47.